Welcome to all of you. In this lecture, we are going to discuss about the analog Chebyshev low-pass filter design. Let us first go through the Chebyshev filter response. Basically, there are two types of Chebyshev filter, type 1 and the type 2 Chebyshev filter. Here, we are going to have a study of only the Chebyshev type 1 filter. So this is a typical response of the Chebyshev filter. So this is the normalized response and this is the actual response. So in a Chebyshev type 1 filter, it can be observed that there are ripples in the pass band. So if this is the case, we consider that as the Chebyshev type 1 response. Now let us go through the magnitude squared response of the Chebyshev type 1. Hn of j omega modulus square is equal to 1 divided by 1 plus epsilon square Tn square of omega, where epsilon square is a parameter of filter related to the ripple in passband and Tn square of omega is the nth order Chebyshev polynomial. Let us go through the filter design procedure. Given the frequency specifications and the attenuation, convert the given frequency specification into radians and the attenuation to dB. So that means frequency can be given in terms of hertz or in terms of radians per second in a problem. If it is already in the radians per second, then we need not to make any conversion. If it is in terms of hertz, we need to convert that into radians per second. Similarly, for the K1 and K2 value with respect to pass band and the stop band, the attenuation value in this case, if no units are specified, then we need to convert that into the dB. If it is already in terms of dB, we need not to make any further conversions. So now to convert from hertz to radians per second, omega 1 is equal to 2 pi f1 radians per second, omega 2 is equal to 2 pi f2 radians per second. Similarly for K1 it is 10 log of to the dB, K2 is equal to 10 log of to the dB. So these two are the stop band specifications and omega 1 and K1 are the pass band specifications. Step 2. Calculate order of the filter. To calculate the order of the filter, we need to calculate first these three parameters. That is epsilon, A, G. Then we will calculate the order of the filter. Let us first go through find epsilon. To calculate epsilon, we are going to have this formula 10 log to base 10 of 1 divided by 1 plus epsilon square is equal to K1. So with respect to pass band specification, we are going to obtain the value for epsilon. Then find A, 10 log to base 10, 1 divided by A square is equal to K2. With respect to stop band specification, we are calculating this A. Then G is calculated in a combination of A as well as epsilon. That is G is equal to square root of A square minus 1 divided by epsilon. Now using the value of G as well as omega R, we can calculate the order of the filter. Omega R is given by omega 2 divided by omega 1. Now the order of the filter is n is equal to log to base 10 of G plus square root of G square minus 1 log to base 10 of omega R plus square root of omega R square minus 1. So remember, if the order is obtained as a fraction during the calculation, then it must be rounded off to the next integer value. The next step, find the normalized frequency response from the Chebyshev type 1 filter table. That is, with respect to the cutoff frequency, omega c is equal to 1. See, there are two procedures in order to obtain the normalized frequency response. One is based on the value of the epsilon. We can go through the lookup table and we can directly write the h of s representation. The another way is make a proper calculation of that without having a lookup table. Make a proper calculation and then we can obtain this h of s representation. So to have a calculation based procedure, this is what we are going to make use of. And to calculate K, there are two cases. If the order is odd, then K is directly equal to B naught. If the order is even, then K is given by B naught divided by square root of 1 plus epsilon square. The last step, apply low pass to low pass conversion. That is, we call it as the denormalization procedure. It can be done by using S is equal to S divided by omega 1. In the H of S, what we have obtained as a normalized filter response, in that representation, in place of S, if we make a substitution S divided by omega 1, then we are going to get the final filter response. Since we are calculating the low pass filter, we call that as low pass to low pass conversion. Let us go through a problem related to the Chebyshev filter. The problem statement: design an analog low-pass filter having ripple in the passband and having the following specifications. Passband frequency 1500 Hz, stop band frequency 2000 Hz, passband ripple 1 dB, then stop band it is 3 dB. So let us go through the step-by-step procedure. So the frequency values are given in terms of hertz. So we need to make a conversion from hertz to the radians per second. Whereas these two are already given in terms of dB. So we need not to make any conversion for these two. So make a conversion for the frequency. Omega 1 is equal to 2 pi f1. F1 is the passband frequency. So 2 pi 1500. We get 3000 pi. The final value after multiplication 9424.777 radians per second. Similarly, applying for omega 2, that is the stop band frequency. So we get 4000 pi, that is equal to 12566.37 radians per second. K1 and K2, they are already in terms of dB, so we need not to make any conversion for that. So it will be minus 1 dB and the minus 3 dB respectively. Now calculate the order of the filter. So before calculating the order of the filter, we need to calculate these three parameters. So let us take one after the other. First, calculate the epsilon. To calculate the epsilon, we are having the formula with the passband specification. The value of K1 is known, so that is minus 1 dB. So make a substitution for that. Now take this 1 plus epsilon square to the numerator, then it will become, the power will become negative. By taking that power to the outside by making the loss of the logarithm, we obtain this expression minus 10 log base 10 of 1 plus epsilon square is equal to minus 1. Take this minus 10 to the right hand side, a cross multiplication, then minus minus that will cancel, 1 divided by 10 will be 0.1. So we are going to get this expression. Now apply antilog on both sides. We get 1 plus epsilon square is equal to 10 to the power of 0.1 and this value will be equal to 1.2589. So solving for epsilon square we get 0.2589. Epsilon will be equal to square root of epsilon square, that will be equal to 0.5088. Similar procedure we are going to follow to find the value of A. So 10 log to base 10 of 1 divided by A square is equal to K2. K2 is with respect to the stop band value. So we know that value, that is equal to minus 3 dB. So substituting over here and after making the simplification we get A is equal to 1.4125. Now calculate the G. G is square root of A square minus 1 divided by epsilon. A square is known, epsilon is known. So substitute and we get G is equal to 1.9603. Now calculate the order of the filter. So the formula is known. Calculate omega R first, that is omega 2 divided by omega 1. So we get 1.333. Substitute all those values over here. Here is the substitution. So after substituting the values of G and then value of omega R and then by simplification we get this as 1.6264. So we have got the order of the filter, but the order of the filter is a fraction. We need to make up it to the next integer value. Therefore, we consider order n is equal to 2. So with respect to order 2, find the normalized filter response, that is at omega c is equal to 1. So in this problem, I am considering making use of the lookup table in order to obtain the normalized filter response based on the value of epsilon, and with respect to the order 2 I am going to have the realization. For order 2, h of s is given by k divided by s square plus b1 s plus b0. The values of b0 and b1 will be taken from the lookup table and it found to be these values. And remember, these values once again in the lookup table, first based on the epsilon value we have to obtain this b0 and b1. Substitute these values in the expression of h of s, we obtain the denominator. To obtain the numerator value k, we must go through this set of formulae, the substitution and the solution procedure. K for even, it is represented by b0 divided by 1 plus epsilon square. Epsilon square is known, b0 is obtained from the lookup table, substitute and we obtain k is equal to 0.9826. So we have obtained the final h of s for the normalized filter. Still we need to denormalize this. So now apply low pass to low pass conversion, that is denormalization we are performing. That is done by substituting s is equal to s divided by omega 1. Omega 1 is a known parameter, that is equal to 9424.777. Now substitute in the place of s of the normalized filter s divided by the value of omega 1. So that is what has been done over here. After making the proper simplification of this, the final low pass filter is h of s is equal to 88.826 into 10 to the power of 6 divided by s square plus 10.34 into 10 to the power of 3s plus 97.93 into 10 to the power of 6. So this is the final filter response. For the order 1, 2 as well as up to 3, we must have this final type of simplified representation. Beyond order 3, the simplification process itself will be very much difficult and also it takes a lot of time. Therefore, we will simply make a substitution and we will stop at that instant itself. So it is supposed to be solved up to this most simplified realization, but due to the complexity of the simplification, we usually stop at that instant itself. So to whatever the extent possible, you can make the solution. Thanks for joining.